The question that I have is, could you do an example on the calculation of ultimate settlement? Here we will consider a horizontal deposit of soil subjected to a uniform surface pressure. I have a clay layer underlying a sand layer. These things are sitting on top of a bedrock. Thickness of the sand layer is 2 meters, thickness of the clay layer is 20 meters, and the soil deposit is subjected to a uniform vertical stress change of 400 kilopascal. The properties of these layers are given to us, and I'm going to do this problem under a couple of different assumptions. First, let's assume that the clay layer is normally consolidated, and we are interested in obviously finding the ultimate vertical settlement of the ground surface. And let's do this in two different ways. Let's first assume that the whole clay layer can be treated as a single layer. In other words, we're going to take the midpoint of that layer, calculate the vertical stress at that point, and assume that vertical stress represents the entire layer. We are interested in the effective vertical stress at the midpoint, right? So what we do, well, we calculate the total vertical stress and then subtract the pore water pressure from that in order to get the initial vertical effective stress at the midpoint. And then we apply the equation we derived earlier in order to calculate the change in weight ratio, and that works out to be 0.32. Note that I'm using C sub C here because we are assuming that the soil is normally consolidated, right? So the initial point and the final point both are going to be lying on the virgin compression curve, which has a slope of C sub C. And then we apply this equation in order to get the value of the ultimate settlement, S infinity, and it works out to be 3.06 meters. Next, I'm going to repeat the calculations with the clay layer subdivided into 4 layers of equal thickness like shown here. So what you do for each of the 4 layers, you calculate the initial vertical stress, initial effective vertical stress at the midpoints of these layers, and they work out to be these for these 4 layers. And then you calculate the change in weight ratio at these points, which are the midpoints of these layers, and they work out to be these. And then you apply the settlement equation for calculating the compression of each of these sublayers. So they work out to be these: 1.21 meter for layer number 1, 0.86 for layer number 2, 0.69 for layer number 3, 0.57 meters for layer number 4. You sum them up, you get the total settlement of the ground surface. It works out to be 3.33 meters. A little different from what we had over here. Next, I'm going to assume that the clay is over-consolidated with a pre-consolidation pressure of 300 kilopascal. We'll keep things a little simple here. We'll assume that the clay can be treated as a single layer. So we already calculated the initial stress at the midpoint of the clay layer before, which was 118.3 kilopascal. So now we know that the initial point has to lie on a swelling line because the soil is over consolidated. The change in the vertical stress is 400 kilopascal, and therefore the final vertical stress is 518.3, and therefore the final point is going to lie on the virgin compression line. We subdivide the total weight ratio into 2 parts, delta E1 and delta E2. Delta E1 is calculated using the swelling line, and delta E2 is calculated using the virgin compression line. We add the two in order to get the total change in the weight ratio. So here are the corresponding calculations. Then we apply the settlement equation to calculate S infinity, which works out to be 1.32 meters. From a practical point of view, a useful observation here is that even though point 2 still lies on the virgin compression curve, the final value of the ultimate settlement of this over-consolidated clay is less than half of what we calculated earlier for the normally consolidated clay. This is in fact the purpose of preloading. You try to over-consolidate the clay as much as possible before you build structures on it, so that your starting point is going to be on the swelling line, and at least part of the settlement is going to take place on the swelling line, which will be much less than if the initial point had lied on the normally consolidation line.